you know, I've been working on this project. You know, it hasn't been successful yet because I haven't done anything to the computer. So I'm going to put a couple of plugs in here for several different people, and I'm not getting paid for any plugs. So the first thing on this camera, I ordered the Hydroxy Technology Corporation, their new, they call it the Powerbox 3. The claim is that it has, you know, a built-in oxygen sensor control, it has a map sensor or airflow sensor control, and also has, those are essentially, it has digital resistors that you can put in line with each of those sensors, and then it'll also control the electricity going to the cell, so it will vary, you know, has a built-in pulse width modulator, and it'll vary real time based on your RPM. So I have that unit, and I'm going to get that installed on that car. I also have a Innovate, what's that called? It's the air-fuel ratio meter.
This one here is Alex startup?
Yeah.
Okay.
Yeah. And I also have it's called the LM1, and it's made by wideband O2 sensor. So I have that, and I've had that installed in the vehicle for a while. And I also have the exhaust gas temperature, also getting that for the car. And so both those things have been installed, and I've been driving that vehicle, and you know, getting just kind of an idea of what it does. And you can very much see that the car holds the air-fuel ratio to 14.7 to 1. You know, it keeps it there pretty much no matter what you do. I did some experiments with, I had a different controller that I could adjust the airflow reading. And so you could lean out the mixture with that, and you could just watch the oxygen sensor compensate for it. And it would just bring you right back. So you really have to do all the sensors, compensate them all, and tell the car, you know, we're gonna run a different air-fuel ratio.
Well, you want the car to believe you're running the
Right.
same air-fuel ratio mixture.
So if you
That's
adjust the
where
temperature-
adjusting different sensors in accordance to what the car expects to see is what brings it to make it lean.
So I would test the sensor, the temperature sensor, and see if it does what the oxygen sensor does.
That's why it's important to have an EGT gauge in your application. People think that they can just bolt a booster on and get instant results with very little user interface. This is not a plug-and-play technology. It requires diligence, and it does require follow-through. You've got to be able to monitor your engine parameters. You've got to keep an eye, especially on your EGTs. Your EGTs are basically it's the heartbeat of the combustion efficiency. It's the best way to tell whether or not you're running lean or rich. Other sensors can give you faulty readings, but an EGT will never lie. If you're running lean, you will see that reflected on an EGT gauge, and you know, as you were already experiencing. And I've experienced with my boosted vehicles, it's a constant, diligent thing. You always have to be watching and tweaking and paying attention to where you're running it.
The next plug, it's not up here, that I'm going to give is there's this open source design for it's electronic gauge to measure your air-fuel ratio. It's called the MP-ENO, and it hooks up to the speedometer signal and to the one of the injector signals, and it basically counts it's able to count the speed of the car, and it's also able to count basically how much fuel is going in there. And I feel like with the scan gauge and a lot of these other gas mileage units, I think that as soon as you adjust any of the sensors in the car, that signal may be suspect, and especially since it plugs directly into the computer. So when people are using those units, that's fine, but I'd like to see, you know, them back up the results with, you know, writing down the fuel, and, you know, each time they fill up. So, you know,
Scan gauges do not work to that. They do lie to you. There's a built-in 4% error, and this has been a topic of contention with a lot of my opposers who are touting the use of the scan gauge, and I discourage that highly. Like I said, there's a built-in 4% error that already exists from the factory, and then, like you said, when you start dealing with sensors, you completely altered that computation. You can no longer rely on it for accuracy. You have to do the volume versus distance method. That method will never lie to you.
Right, you can back up your scan gauge data with that, and that's the way you should be doing it if you're using scan gauge at all.
And just another back to the MPG, I feel like that would be less effective because it's taking the signal, basically the only things that are going into it is the speedometer data and the injector pulse width, which is what we're trying to change anyways.
And either
So-
way, even if you use that, as long as you back it up.
Yeah, anytime you can back up your data with another method, it just gives you more and more credibility. The next project I've been working on is we have this biodiesel rig that, it's the university's rig, and I'm working on getting some dyno results for my latest cell here. It's actually sitting out there, and we did a test, and I'll read the numbers off.
So that's running on biodiesel.
Yeah, 100% biodiesel. So me and Smack, we ran a test on this cell, and the input voltage was 14 volts, and we had 7.1 amps going into it. And we were producing, and the cell we had just started up, so it was relatively ambient temperature.
Yeah, it's cold.
And we got 676 milliliters per minute. So the efficiency on this cell comes out to be about 8.7. So that's one of the biggest numbers I've seen.
What were you using to test the amps?
It's a clamp on.
And that also, his result, our cells are very similar, his cell and my cell are very similar in construction and design, and we're both kind of really psyched about, this is peer review. Jake is obviously non-biased in this. He really didn't know what his MMW readings are, and some other people who've been on my YouTube channel are aware that I have a 24-volt system where I posted 9.1 MMW, and a lot of people say that's impossible, but we've done a peer review today, and we've seen a very close replication of those claims, so
So
we're on the right track.
14 volts, 7.1 amps. 14 volts, 7.1. It's actually 100 watts, 99.4 watts.
100 watts. Well, I think it's really good. Half a liter at 100 watts.
The numbers, man.
So back to the dyno testing. We put the vehicle on the dyno, and this dyno probably at the university they do a lot of work with biodiesel, and so this dyno was back when they were doing testing on the difference between biodiesel and normal diesel, and they haven't run this dyno for about 2 years, and so it's a little bit out of tune. So we put the vehicle on there, and we got the cell going. This time the cell was just built and had some leaks and some issues. So, we ran the test. I'm not ready to put out any data on it, but this is something that I'm working on, and I'll, continue to work on and getting this test. It's a little bit, if some people have some ideas, people have boosted diesel before. Basically what we did to inject the gas was we lifted up the air filter housing and stuck the output of the tube right in.
And the air filter box?
We opened the air filter box and just kind of stuck it
This
down
is
the
a
intake.
turbo, right?
Turbo, yeah.
You want that injection point as close to the turbo as possible.
Okay. And let's see what else. The other issue I need to do with this is the gas. When we were running it and putting the gas in, there was definitely a lot of water going in there from the bubbler. When you have 5 liters per minute going through a small container.
You're throwing 5 in there?
Yeah.